Hello guys, now we are going to see our next topic, that is stack using linked list. So let's move further. First of all, we will compare the properties of stack and linked list. So stack, this is how the stack looks, and linked list, this is the nodes of linked list. So what here we are going to do, basically we are going to make linked list work like a stack. Now how stack works, you know that stack works in last in first out order. Means last in first order in the sense like we are first pushing some elements into the stack, like first we pushed 5, then 6, then 9, then 2. Now here while inserting these elements in the stack, you know that the last element is 5. So last in means the element which is at the last will be in, but the element which is at the first place will be out. What do it means? When we are pushing the elements in the stack, at that time 5 will be in, that is 5 will be deleted at the last. But whereas at the time of popping elements from the stack, the first element which stands in the stack will be deleted first, that first will be out. So this is how stack works, and we are going to make this linked list to work as like stack. So instead of this 2, 9, 6, 5, these values, what we are going to do, we are going to insert node, or we are going to pop nodes also. So you know that when we have done the program of stack using array, at that time the top was in the form of index positions of array. Like here the top is now pointing to the 3, right? The top will be 3, but what will be the stack of top? Stack of top will be the value, that is 2. So here what will be going to happen here in linked list is like we are supposed to insert nodes in the form of stack. Suppose this is stack, I will draw it. So this is stack. Now in this stack I am going to push the nodes, that is first node will be 25, then 32, then 50, then 99. But at the last what we are going to do is, while popping this node, this top will point to the address of this node, right? So what is going to happen here, in stack using linked list, at this time top will be addresses of node. So this is how stack works and linked list works. So here now we are going to focus on the actual code of stack using linked list. So what we are going to do here, we will first create one node whose name is temp, like this, and then we are going to perform certain operations on it, such as push operation and then pop operation. So let's begin. So at the very first we have to make one node, right? So for that what we are going to do, we are just following the steps which we have followed before in this singly linked list. So at the very first, construct the structure of node, that is struct node. What it will consist of? Int data. One is the data part and the another one is the next part. So struct node asterisk next. Fine up to this. Now next, after making this structure of node, I will make one function, that is void push. 1 second here. Yeah, void push. So this function will be doing a work that it will push the node into the stack. So at the very first we will declare our node which we are going to push into stack, struct node asterisk temp. Then at the first we declared the temp as a node which we are going to push into the stack. Now we will allocate memory to it. So temp equals to struct node asterisk malloc size of struct node. So here we go. Now we have allocated memory to our temp. Let me make this white. Yeah. Now memory is allocated. Now it's time to set the pointers of it. But before that, we are going to give one message to our user that enter the value to be pushed, right? So now I gave message to my user that please enter the value to be pushed into the stack. Now we have to store that value. So what we will do, we will declare here one more variable int info. Now let us accept that through scanf. So I'm accepting it through scanf and I am going to store it into info. Now the value which you want to input into this stack has been stored into info. The next step is we have to insert this value, this info, into the data part of temp. Yes, because we aren't going to push only the value which user has given to us. We have to push the whole node into the stack because the program itself is called a stack using linked list. So we have to push the node into it. So let us temp of data equals to info. Now the value is stored into the data part of temp. Okay, let me correct this. Data equals to info. Yeah. Now info is stored into the data part. Now what will happen here, as soon as you will try to insert this or push this temp into, one second, I'll show you. As soon as you will try to insert this temp into this stack, what is going to happen here? At the very first top was pointing at the address of 5000. Now this top will point to the address of 3400 because new node is inserted into it, and that's why the address is going to change of top. So top will point to 3400. So we have to make these changes into the code. So let us make these changes into the code. So temp of next, right? Temp of next will be top. That is what is happening here. The next part of temp was at first was 3000. This was the memory which was allocated by temp by malloc to temp, right? So here now this 3000 is going to change and it will store the address of the next node, that is 5000. So here the changes which are going to happen here, we have made this into the code. And also now you know that top has been changed. So top is pointing to 3400 means top is pointing to the address of temp. So this one more change we have to make here, that is top equals to temp. Now the node which we have inserted temp is top, right, at the moment. Okay. So this is how insertion works. This is how the push operation works on the node. So here we will insert at the last that inserted value is %d. What was the value which inserted? Temp of data. Yeah. So this is the whole code of pushing the node. Now let's focus on popping the node. That is deleting the node from the stack. Let me, yeah, I think now it will be visible to you. So here, first of all, like in, where is my void push? Right here, like in pushing the node, we first made one function that is void push. So here also we will make one function that is void pop. So in void pop, again we have to declare the node which we want to pop out, that is we want to delete. So temp will be the node which we want to delete. Now here first we have to check if the stack is empty or not, right? Because if stack is empty and still we are trying to delete the nodes which are present into it, then it will result into the underflow. So first we have to check if the top is pointing to null or not, means if this stack is empty or not. Yeah. So after doing this, we will come to know if the stack is empty or not. If it is found that stack is empty, then we will simply print the message that stack is empty. Stack is empty. But it is found that stack is not empty, then what we will do? We will take one else part, and else part will consist of, first what we have to, once again, yeah. First what we have to think about that this temp, now this temp is the, at the moment, the one value which, the one node which we want to delete right now. So top is pointing to temp, right? But let me tell you, you can't delete this temp directly. Means you can't make changes like we are deleting nodes certainly, like temp is deleted and we are just freeing up temp. This is not the case in the stack. So what we have to do, we have to temporarily store this top into another variable. For example, here I am storing this top, at the moment this top is pointing to 3400. So let us store this top at in temporary variable, such as I will store this top in temp. Okay, temp equals to top. I store top into temp. Now what will be the next part of temp? Now this temp is removed, right? I'm storing this temp into another variable, means this temp is removed. Now this top will point to this, right? As soon as you will try to delete the first, this one, this node, this temp, this is now deleted. Now obviously it is pointing to the next node, that is top is pointing to 5000 now. So these changes we have to make in code, that is temp of next. What is temp of next? Temp of next was 5000, means this. So now here top will equals to temp of next. Top will equals to temp of next. Right? This is top. Temp of next is 5000. It means that temp of next, which is 5000, top will point to that. That is top will point to 5000. This is the meaning of top equals to temp of next. Now we are done with these changes. Now we will print a message that %d is deleted. And what will be that %d? It would be temp of data. So this is how pushing and popping operation works in stack using linked list. You can make one more function, that is void display. So in that what you have to do, you have to just set one while condition, that is temp does not equals to null, or else I will show you here that how display is done. Okay, I'll add up here only. So let us make another function void display. So what do my void display will consist of? Again you have to do the same thing, that is struct node asterisk temp. So I will just simply copy this, I'll paste it. Yeah, now our struct node asterisk temp is the first node at the moment. So again in displaying we have to check if the top equals to null, means if the elements aren't present in the stack, so what it is going to print, right? So that question arises in mind. So for that, to handle that case, what we have to do, we have to simply check out first whether our stack is empty or not. So I will take this condition again here. Now, after doing this, in else part, if there are certain nodes in this stack, so what we will do, we will again store this temp. In the temp, we will store top. Now top is stored at temp. We will take one while condition, that is temp does not equals to null. What do it mean? It means that we are traversing in this stack up to which node? Up to this last node. And what is the condition of the last node? The condition of the last node is that the next part of the last node is null. So until we do not reach, means until we do not reach up to this last node, we are going to print the nodes which are present previous of them. So printf, what it will print? %d temp of data. Temp of data. And as we have to traverse it, so how we will traverse? Again, the same way we have traversed temp equals to temp of next. So right now we just have studied how the stack using linked list program works. So here we are going to run it on codeboard.io ID. So let's run it. At the very first, I have compiled it and it is showing that compilation is successful. What I have done in this program, I have just appended the parts which we have seen here, that is void push, void pop, void display. I have just added this in one program only. And I have used switch cases here for just enabling you your choices. Then first one is the void push, second one is the void pop, and third one is void display. This is another one more function which I have added in my program. So here what I have did is the only the repeat thing which we have did before, that is I have created one struct node, that is asterisk temp. Then I have checked whether my top equals to null, that is if my linked list is empty or not. Then if it is empty, I am printing that stack is empty, else my temp will equals to top. It will this is the temporary storage which we are going to do. We have to store that top into the temp so as to not get affected the address which top is pointing to. Then what we are going to do is we are using this while condition, while temp does not equals to null. Temp does not equals to null means we are traversing our stack till we do not reach to our last node. That is, last node is consist of one node which is having its next part pointing to null. So that is only the condition we have taken here, that is temp does not equals to null. Then we are printing that data part of temp, and also we have to traverse as we have to print each node's data part here. So we are traversing with using this code in our line, that is temp equals to temp of next. So let us run this program now. So it is asking me my choice. One second, I will make it bigger one. Yeah. So I will input, let's say I want to push. So which value I want to push? Let's say 45. Yeah, inserted value is 45. Now I will again push. Which value I want to push? 34. Enter. 34 value is inserted. Again we will push so that we could perform pop operation on it. So which value I want to push? 67. So right now what my stack will be consist of? Stack will be consisting of 23 and 34 and 67, these three values. But at the moment my top is pointing to 67 now, right? I will try to do pop operation on it right now. So for popping we have to enter the choice 2. So here deleted value is 67. So why it is deleting 67 only and not the other one? As you know that stack works in last in first out order. So here the value which is right now pointing to top, just I said before that at the moment our top is 67. So here the value which is pointing, the top which is pointing to the value is deleted at the first, that is 67 is getting deleted at the moment. Now my top will be pointing to 34 because 34 was the value which was under the 67. So let's do once more it, that is we are popping once more. So deleted value is 34. Why? Because as soon as 67 was deleted, top was shifted to 34. Now my top was pointing to the address of 34, that's why 34 is not now popped out. Now again my top is shifted to 23 because 23 is under 34. So again we will do pop operation and it will delete the 23. So this is how the program works. So hey guys, thank you so much. I'll see you in the next class.